61 based in Perth, and I have the pleasure to host this session. I'm the Posters chair for this year's VRCAI, and I'll present this session on behalf of the Demos chairs, Sandy Russell and Tim Marsh as well. Okay, so we have a very tightly timed session. Okay, thanks. And sort of, if I can just ask all presenters who will present in this session to either sort of wait in the alleyways on the side or be very close to it so that we can have a very quick handover between presentations. So what you see here is we're going to start with the poster presentations, and there's a list of all posters, and after we finish with the poster presentations, we'll have the demo presentations. As we already heard this morning, we had a total of 23 posters submitted or accepted. 18 of them are presented in the session, and out of the 12 demos, we also have 11 represented in the session. For each presenter, we have one title slide, which lasts for 10 seconds, and one content slide for 45 seconds. And each slide is timed automatically. So if you see that your slide disappears, then we ask you kindly to leave the stage and make space for the next person. Or Sandy removes you.
You only have, correct. I'm sitting here to physically drag you off to, you have to keep to your 45 seconds. Otherwise, this thing doesn't work.
Yeah, so anyone who's been to fast forward sessions, they'll probably know that you can expect a bit of chaos, but I guess that's all part of the fun of it. So if the first presenters, what you see, the names are always the first author for each presentation. So if you're not the first author, then please find your respective first author in the slot where you presented. Hi, Stuart. That's a good start. So, with that, I would say we get right into it.
Am I in charge?
No, it's all right.
Hey everybody, I'm Stuart, and I'm here to talk about an evaluation of augmented reality for music notation. So I actually wasn't really involved with this work. My colleagues Zero and Henry are, but I'm going to do my best to talk on their behalf. So what we wanted to do is explore the application of augmented reality within music performance. So being able to introduce some sheet music into an application, into a head-mounted display, and you play along with your music, and this interactive thing appears before you, guiding you as you play. So we built this thing for HoloLens. We did an evaluation with some expert musicians. And generally we found the idea was not quite as silly as it sounds, got quite some positive feedback. We need to further develop the way in which we can position the sheet music as it appears, because we didn't have enough flexibility there. And we want some annotation functionality in there in future is another thing we discovered. But we think overall there's some good opportunities here for new forms of musical practice. Thanks.
One quick thing that I forgot to mention, there's also an indicator who's the next presenter on the top right.
Okay, this is Frank again. So we're bringing you a new eye tracking data set for visual attention modeling in the virtual museum context. So predicting users' visual attention enables aware environment to be adaptive and provide a context-aware and interactive user experience. So we have seen lots of work predicting these things, but always limiting themselves into the space. So now we built the first 3D eye tracking dataset for visual attention in a VR environment. It comprises about 7 million records of visual attention from users during their navigation in the virtual museum. So come and take a look if you're interested in building your self-predictive model on 3D eye tracking data. Thank you.
Somebody can memorize this slide. There you go. Theodore. The next one up is Asako Soga.
Okay, cheers. Okay, so talking about containerization of game levels and serving it up. Look, containerization is not new in the games environment, especially for development and actually serving up game levels to customers. It's also not unusual for multi-user services. But what we're trying to do here, because we're trying to serve up combat simulation rather than game levels as such, they're just built using a game engine. We've actually come up with a system that streams video, and what we can do with that means that the client device itself doesn't actually have to have something like Unity installed on it. It can be a very thin client, so it's like a VNC type environment, basically a remote desktop. Early days, it seems to be working quite well.
Very cool.
Wow.
Hello, I'm Asako Soga from University. integrated body part motion sensing system. By using this system, user can create some dance choreography very quickly and easily. So, and I will introduce a demonstration of this system, and I explain as I bring some movies, videos of performance. I actually created live performance by using this system last June. So I introduced this one. So thank you.
Come on up. Whoever's next.
Give him pardon. Next one up is Minori Uno.
Where's Bernard?
Hello. Let me introduce integrated AD system called EIs. EI is a wearable device attached to glasses. EIs was developed for the blind and people with low vision. EIs provides useful service such as reading text and recognize objects, and it includes stick hand gesture recognition technology. Thank you.
Next one up is Oliver Locke.
Hi, I am Minori Uno, the Tokyo Metropolitan University student. We aim to transmit bodily sensation by relying one's past experience, and our goal is develop reliving system using vestibular stimulus for seated user and generate turning walking sensation by asymmetric roll and lift stimulus. And this time we quantify both turning sensation and walking sensation under different initial roll angles of vestibular stimulus. And the moving by the display shown at the videos, but it's not working. As a result, vestibular stimulus with initial roll angles could impart the sensation of turning walking to the sitting laser. Please come to our poster session. I'm ready for the videos. Thank you.
Okay.
Hello, I'm Oliver Locke from UNSW. This is Hollow City, augmented reality cityscapes for analysing high volume urban sensor data. So the idea is that every minute of the day, hundreds and thousands of GPS points for performance variables, how crowded the train is, how delayed it is, how crowded buses are, how late various things are, etc., are put out as feeds in the urban environment, but they're not captured. So this idea is to allow transport planners and urban planners to look at hundreds and millions of pieces of information from the public transport network over time, historically, to look at different trends and explore them in augmented reality, as well as that you can look at them in real time, and everything is developed using open source software. And this was came as a result of trying to use things like Mapbox and Esri products, and they were closed and they were slow. So how do we use open platforms and open data to explore these huge amounts of feeds that are now becoming apparent in our environment? And that's about it. Come and see the poster.
Thank you. Next one up the combat is Riot Anthony.
Yeah, so this is our try for doing computational fluid dynamics using augmented reality. So especially very heavy simulations. This use case was on magnet hydrodynamic simulations, when you can simulate various phenomena and visualize the flow just above your table. And when you're doing, like investigations, you just use AR for investigating different points in the volume or getting like stick lines and stuff like that. So come and talk to me at the poster.
You had way more time.
Okay.
It looks awesome. Can dance a bit.
Because you should have timer, going for.
It is a timer.
He got extra time.
Yeah, so my name is Ryan. My topic is about integrating mixed reality and Internet of Things as an assistive technology for elderly people living in a smart home. So our world's population is aging, and it's expected that the number of older people will double by the end of 2050. So this research explores on how in the Internet of Things and mixed reality can be combined and directly usable for elderly people for reliability, usability, and suitability for everyday use. So it combines different kind of emerging technologies such as IoT for remote control, object recognition and scene analysis, and wayfinding and navigation. So basically, older people knows where they could ask for directions. So the system knows if where the keys are. So they could just say, "Oh, where are my keys?" and the system will tell them where the keys are. So if you're interested, you can visit the poster. Thank you.
Next up, Katarina. Then we have Mauricio Souza.
Hi, I'm Katharina Krösel from VRCAI. To be prepared for flooding events, disaster response personnel has to be trained to execute developed action plans, and we present a flood response training system which connects an interactive flood simulation with a VR client. The collaborative operator trainee setup of our system allows a trainee to steer the remote simulation from within the virtual environment, evaluate the effectiveness of deployed protection measures, and compare the results of different simulation runs. If you want to learn more about our system, come to our poster.
Mauricio.
So, okay, my name is Mauricio. Not really. Somebody had to come here, and it's a difficult work. But the whole idea here is, how do you get people to improve communication between people in a remote collaboration setup? And we come up with this idea of negative space, where you have two people in a video conferencing setup or in augmented reality with the three objects between the three of them. And we propose this concept of negative space to promote a shared understanding of task space, how people could reference to different parts of the engine, and how you can refer to occluded parts of the model when you are in a situation of face-to-face. If you want to see more, come to our poster.
Thank you. Hi everybody, quickly, my poster is just a part of a bigger study which explores gamification, sense of place, augmented reality, micro-location and service dominant logic together. And this is the second iteration which looks at the implementation of the augmented reality component into the app. We're using Unity engine, VRCAI, and it's all applied to indigenous artwork, to the largest indigenous artwork to probably in the world, hosted at the Bond University. You're all welcome to come and take a look at it. And it's looking how and why and if gamification of microlocation can or will or could increase the sense of place. Thank you very much.
Hi, my name is Paul Niels. I'm here on behalf of Maria Rita, and which is my student, and the work is about painting with movement. That means that she is currently using non-expensive body motion capture with a laptop or a tablet, for instance. And the idea is of capturing the body motion and doing some expression with that. So she's a dancer, and she's a dance teacher. So she's willing to convince more people to come to dance and to see what they have done with those 3D paintings that can be observed from any point. And that's it, basically.
Mauricio again. So we have this idea of diminished virtual reality. What is that if you want to dance in a virtual environment, but you have to do it in the comfort of your own sleeping quarters? It means that you're going to stumble in your bed, you're going to hit your head against the wall. And the idea here is to augment the virtual environment with proxies for the obstacles, so you can still do your dance without hitting the furniture or without the furniture hitting you. And if you want to know more details on how we did that, please come to our poster. Thank you.
next one up should be Carla.
Hello, my name is Allison. My poster is called Snapchart, an augmented reality and analytical toolkit to enhance interaction in a collaborative environment. It's basically a system that encourages people to use mobile AR devices to enhance the engagement for immersive analytics collaboration in a practical, agile environment. Basically, just scan the data on the whiteboard and then project it into your iPad and basically interact with your collaborators to see how 3D visualization works within the AR environment. I guess that's it.
Thank you.
So hello, my name is Carl. I'm going to present just one slide for my project, which is superimposition of 3D scan on a part. When I'm talking about the part, I'm talking about like an industrial part or a real object, like let's say here a Buddha. So first we pre-scan the Buddha with a 3D scanner. Then on the HoloLens we do a stereoscopy to find the markers. Then we do some optimization and filtration of the points. And after, when we recover the pose, we can superimpose the model on the part. And the results are pretty good. It's pretty precise, like 2 or 3 millimeters between the reconstructed point and the real points. And we can check out the video real quick with the QR code, but I'll show you at my stand.
And afterwards, Kazuya.
Hi, I'm Nils, and I'm going to present you my work on digital laboratories. The idea is to create a virtual replica of a real laboratory and let students perform experiments virtually. The results are transferred to the real laboratory, which has some sort of automation and replicates the steps the students did. And then the students receive later a webcam recording and real experiment data in a learning management system. Thank you. If you're interested, you can come to my poster.
That should be the last pause, and then we move on to the demos.
Hi everyone, I'm Kazuya Nakamachi. Our research theme is perspective taking. Perspective taking is a basic human ability to infer others' mind or feeling. We ask subjects to judge the gap orientation of the stimuli from the direction of a chair or humanoid avatar. We found that the existence of humanoid avatar makes judgment faster and more accurately. The virtual avatar enhances our ability of the perspective taking, and that might contribute to our social communication. Thank you.
So now we have 11 demos presented for the first speaker, please.
Okay, thank you. I'm Patrick from City University of Hong Kong, and our demo is about embodied weather, and it is a virtual reality system about storytelling, and it is to tell the public of Hong Kong about how to protect themselves in the weather, the extreme weathers in Hong Kong. And you can experience when you go through the Jinja Street of Hong Kong Street, and then you can feel the fog and the wind and the rain getting stronger and stronger. And that's what our demo presents. And if you want to explain these things, you can go to 117. Thank you.
continue here. So Donovan and Shana has been around. They are certified midwives and nurses from Charles Stewart University. In this project, we presented a possibility of two conditions in mixed reality using HoloLens and also virtual reality using STEAM VR system of visualizing 40 weeks of midwifery experience. And one of the main contribution here is to look at how such system can be used for actual education system. And according to what we have been doing, the project is now collaborating with University of Illinois, one of the largest education provider for medical.
Alright, I'm Wei Hong from University of Otago, and today I'm presenting you AR Spectator. So basically, when you go to the stadium to see sports, you don't have commentary, you don't have live games, live information and fancy visuals. So we want to bring this to the stadium via mobile augmented reality. So for this demo, we are demoing 2 of the 3 prototypes here because we can't bring the stadium here. So later you can come and have a look at what it is. And the project consists of a team, and I'm mainly focusing on the visualizations. So for those who are going to SIGGRAPH Asia, feel free to take note of a technical brief by my supervisor, Stephanie Zolman, on AR Spectator, and you get more technical details there because, yeah, it's a demo. Thank you.
Hello, I'm not Kate Patterson, but I'm representing the team. So basically, at the Garvan Institute of Medical Research, we get a lot of tour groups coming through. These people are potential philanthropists or just lay people that are coming in just interested in the science. But during the tour, they don't really get a context of what the scientists are actually doing. They just observe scientists moving colorless liquids from one tube to the other. So our take on trying to contextualize that was using Unity to create this sort of interactive nucleus experience where you shrink down to the size of a molecule and go into the center of the cell. And yeah, so along that, we sort of came along with all these interesting questions. What would it feel like to grab DNA, wave it around? What would it look like if you're triggering transcription by physically placing a molecule on the strand of DNA? And yeah, so if you're keen to see what our take on those sorts of things are, come look at our demo.
So yeah, Conan is coming tomorrow, so I'm presenting for both of us. We have something special that's coming up. We're opening our platform, which is called High-End Visualization System, that will allow you to run a bunch of different VR and AR solutions across a variety of hardware solutions. So whether you run stuff on AR, VR, whether you have cluster-based systems like cave systems, whether you have hemispherical domes, you can run it interactively. We brought as well for you as a demo like a small mini center we have in Sydney, so you're going to be able to see that during the demo session tomorrow. And if you want to hear a bit more about the framework, just come and ask us. Thank you.
Our demo is called the Multi-User Cellular Arena. It's a novel 3D data visualization experience emphasizing virtual avatar co-location using customizable VR avatars. The work explores the utility of building collaborative VR spaces with consumer-grade VR hardware and the importance of user embodiment in these sorts of experiences. Our demo paper also emphasizes and documents the workflow from raw microbiological Z-stack DICOM data to interactive VR experience using mesh shell caches as our display format. Noting the particular design challenges of having different people in this same virtual space, avoiding collisions and challenges like that. If you'd like to come and check it out, do so.
Present, or we might just have a good look at the slides.
Relive the history.
You want to narrate it?
It's all, yeah. the old place?
We got an empty slot. Let me just quickly say that we actually just right now that there's one slide missing. So after we finish this slide, then Alicia will present her poster as well.
It's a meditation time.
Who's that? Yeah.
Okay.
Yes. Hello again. I'm Z from Newcastle. This has been an official collaboration with Newcastle Art Gallery and also the City Council. Not sure if there's a way to play this video, but as we can see here, Newcastle Art Gallery currently is hosting one of the largest non-functional avant-garde ceramics known as Sudacia outside of Japan. We have recreated a forest based on a theme connected to Australia. The idea is to break the computer, but we regretted about it, and we use anti-aliasing solution to bring natural look and feel of the forest. Do come and try our demo. Thank you. And hello again. I know that Philip's supposed to be talking about this by himself, but he's very interested in the indigenous demonstration at level 1. So recently we have won a small grant to support the continuation of this project. In this demonstration, we introduced 2 kinds of experience. A person could try the augmented reality with audio being enhanced with external speaker, or it can be simultaneously done with multiple users. It is a way for storytelling, and also we bring about the idea of decolonization and promoting Torres Strait Islander in indigenous art. Thank you.
Hi, I'm Jayesh from IIT Bombay, and our demo is Till We Meet Again, a CineVOCAI experience. So, yeah, when it comes to VR cinema and storytelling, there's a lot of challenges. So, some of them being traditional storytelling methods needs relooking, and especially users have the complete freedom to choose their point of view while the VR experience is going on. So, how can we use this to our advantage is what we thought, instead of seeing that as a problem. So here we present a form of responsive cinema that where the storylines are driven by the user's point of interest and where they look at, and it's called CineVOCAI. Until We Meet Again is one of our first prototypes that we're putting out to public. So if you are interested, please come and look at our demo and see what stories evolve for you. And your feedback will be really appreciated. Thank you.
I'm Benjamin Mamafadil. Our demo is Motor Bodies VR Interactive Narrative and Gameplay for Social Impact. So we explore the use of VR immersive and interactive narrative gameplay to bring about the conversation about plastic pollution, particularly about microplastics that's in our body. The narrative then brings to the journey to the virtual stomach, and where you can see the microscopic creatures like copepods and tardigrades that they're feeding off amongst the microplastics. So at the end, this creative practice and research is give people an engaging and empathetic qualities to raise global issues and awareness about our environment. Thank you.
Thank you very much. So that was the last demo. As I mentioned, we have one missing poster presentation. I apologize for that.
Yeah,
So we have Alicia. Are you sure?
Yeah, absolutely.
Okay.
Oh, it's okay.
You can take 50 seconds.
Hello, I'm Alicia. I'm part of the Griffith Film School here. I'm doing my PhD at the moment, but this is actually my honours work from last year. It's outside. There's a big pink poster. I'm a sound recorder in TV, and I really wanted to look at spatial sound in 360 film and VR. My honours work was looking at how we bring a cinematic approach to 360 film, and a couple of the key findings that we had. Everybody talks about like trying to control an audience where they're looking, how to help guide them through an experience, and sound is a big part of that. I interviewed a bunch of different people that had worked in VR sound design and found that one of the best ways to do that was bring the sound designers in early. even to your pre-concept meetings, and then they can actually help like create these sources. Another one is that we needed to thin out the mix in post-production, so people were just getting a bit overwhelmed by the experience, so we had to pull some of our sound effects out. And I also developed a location sound report for ambisonic recordings. So if you've used those ambisonic mics, which are like the spatial microphones, it can get really confusing about which way they're facing for post-production. So we've developed a sound report for that. Please see my post for more info.
Okay, let's thank our speakers again. So the poster and demo session is tomorrow afternoon, and I hope we see all of you there. Thank you again.